In this video, we will review some of the issues and strategies involved in naming organic compounds that contain functional groups. We will also explore how we can use the online drawing program, Marvin Sketch, to draw such compounds. This slide shows the bond-line drawing for two organic compounds and their corresponding IUPAC names. The name for the left-hand side molecule has 5 parts or subunits. The carboxylic acid functional group determines the suffix, oic acid. Part 2 and 3, AN and BUT, indicate no carbon-to-carbon double bonds and that the parent chain has 4 carbons, respectively. Part 4 indicates the presence of the hydroxy substituent on carbon number 2. In this case, because the alcohol functional group has lower priority than the carboxylic acid functional group, at least in terms of IUPAC naming, it is treated as a substituent. Finally, Part 5 indicates the RS configuration about the chiral carbon number 2. The name for the molecule on the right-hand side shows a 5-carbon chain, PENT, no carbon-to-carbon double bonds, AN, and no functional group, as indicated by the E suffix. The substituent in this molecule, however, may give rise to some confusion. It is referred to as the ether functional group. This points to the fact that organic chemists think of functional groups in 2 ways. One way pertains to the collection of atoms, usually involving heteroatoms like nitrogen, oxygen, and sulfur, that define the suffix in the IUPAC name of an organic molecule. The other way pertains to the bonding pattern of atoms that define or predict a certain chemical reactivity. The carboxylic acid fits into both of these categories, whereas the ether group fits only the last category. That is, it predicts reactivity, but it is not used to name the suffix of a molecule. The name 2-methoxy indicates that there is a 1-carbon ether attached to carbon number 2 of the parent chain. Ethoxy would correspond to a 2-carbon ether, propoxy a 3-carbon ether, and so on. As a last point, notice that carbon number 2 in the right-hand side molecule is also chiral. But because we have not shown any stereochemistry, that is the wedge or dash notation, we cannot assign R or S configuration. We now turn our attention to Marvin Sketch. We see 6 instances of 5-carbon chains. We will turn each of these into functional groups according to the labels. A helpful strategy is to create a bond skeleton with only carbon atoms and implicit hydrogens, and then replace the carbon atoms as needed. For instance, for a carboxylic acid, we can add a second bond onto carbon number 2, click on the bond to change it to a double bond, and then add the 2 oxygen atoms. A similar approach is taken for the other functional groups. Notice that the Marvin Sketch software is smart enough to add any required hydrogens on heteroatoms like oxygen and nitrogen. As a wrap-up, let's draw our 2-hydroxybutanoic acid, one of the molecules we saw on the first slide. Clicking on the top left icon brings us to a fresh screen. It is worth mentioning that should you click on this by accident, you have not lost your work. You can simply click the Undo button to return to the original screen. We make a 5-carbon chain, add a bond for the OH group, click on a bond to change it to a double bond, and add a wedge at carbon number 2. Then we add the appropriate oxygens. We now want to check that we've drawn the molecule correctly. As before, we do this by clicking on the Export button. Then, in the drop-down menu, we select Smiles and copy the code. We now return to the tutorial and paste the code in the answer box. Checking the answer should verify that our answer is correct. Please run through this example yourself. In the next slides, there is further practice concerning functional groups.